Alrighty, I got you. Ooh, I lost my window. I got you here. We got one more video happening for us for this set. There it is. Okay, so what we're looking at now, we talked about balancing things in terms of acidic conditions. Now we're going to look at things in terms of basic conditions. Okay, so this is basic conditions. Um, the nice thing is everything we talked about in terms of acidic conditions is going to also apply to basic conditions. So our atoms have to be balanced, the charge has to be balanced, and all that stuff. Okay, so if we look at our steps again, um, these are the same steps. So like in the beginning, all of these are the same things that we're going to do it. So I like to say if it's basic, the first step is to balance it and pretending it's acidic. Okay. Once it's acidic, we're going to add these steps in and just convert our acidic, our acidic equation into a basic equation. Okay. So this will give us another help with practicing balancing acidic, and it will also show us what to do about basic stuff. Okay. Again, we're going to have to write a skeleton. So um, again, I was mean, so we're going to have to make us remember how to name stuff. Um, but here we have a basic solution. We got to make sure we know that. Um, we have permanganate ions again. So that's MnO4 minus aqueous. React with sulfite. We did permanganate. We have sulfite. Sulfite is SO3 2 minus. Remember, just go through those polyatomic ion sheet. That's up there again um, to practice what the names of these polyatomics are if we forgot them. Um, okay, this is going to produce sulfate, and sulfate is SO4 2 minus, and it's going to give us some solid manganese 4 oxide. So that's MnO2, and we told it was a solid. There's our skeleton. Okay, cool. So now we're going to balance it. On our first step here, okay, one, I'm going to make it look nicer. And two, our first step here is we're going to balance this the same way we just did, thinking of pretending that it's acidic. Okay. So we want to assign our oxidation states as we do this. This one's a little bit more tricky. Um, this one we were told in the name that this has to be +4. Okay. All of our oxygens are -2, so just remember that. So we're just going to work our way to the left here. This is 2 minus, so this is -8. So that means the sulfur has to be +6. Okay. This is 2 -2. So this is -6. So the sulfur here has to be +4. This is -2. So this is -8. So this manganese has to be +7. Okay. And we saw how to do this before. We're going to do our oxidation half. Then we're going to do our reduction half. Remember our oxidation half, the oxidation number has to increase. And so that is the sulfite turning into sulfate because it went from +4 to +6. So we're going to say SO3 2 minus. I'll put phase labels in again at the end, SO4 2 minus. Okay. Then our reduction half is the other half. So manganese is going from +7 to +4. So that means our permanganate is being turned into MnO2 or manganese 4 oxide. All right. So remember, we have 4 things to balance for the halves. We're going to balance all of the atoms first, which except for hydrogen and oxygen. So sulfur is balanced, manganese is balanced, so that's done. Then we have to balance the oxygens by adding water. So here we have 3 oxygens and here we have 4. So we need 1 water on this side of the SO3. Okay. And then on the manganese half, we have 4 here and we have 2 here. So we need 2 waters on this side. Okay. Now the oxygens are done. What's left is hydrogen. So let's do hydrogens. Okay. And we're going to pretend it's acidic. So we're doing hydrogens by adding H plus. This has two H's over here and none over here. So we need 2H plus on this side. In the reduction half, we have four H's here, so we need 4H plus over here. Okay, then lastly, we need electrons. Do electrons in green. Remember, we have to make it add electrons to the more positive side. So this side is -2 on the, that looks like that. On the reactant side, because it's -2 and 0. This side is -2 and +2, so this side needs 2 electrons. Okay. In the manganese half, the products are 0. Excuse me, sorry. Products are 0. The reactants are +3 because we have +4 and we have -1. So this side has to be 3 electrons. So all that cancels out. Okay. Now we need to cancel out electrons. So we have to multiply by stuff. Okay. Which means we have a 3 and we have a 2. So that means the oxidation has to be multiplied by 3 and our reduction has to be multiplied by 2. Okay. So, yeah, I'm going to go ahead and rewrite these so we have them neater. Let me draw a line. All right, so our oxidation multiplied is 3 sulfite plus 3 water makes 3 sulfate, 6H plus, and 6 electrons. Okay, then our reduction half is times 2, so that's 2 permanganate, 8H plus, 6 electrons, 2 MnO2s, and 4 water. All right. Now we want to add these together and we're going to cancel anything that cancels. Okay. So if we add these together, of course, the electrons have to cancel. There's 6 over here and 6 over here. All right. I'm losing it. I'm losing it. I've lost my window. There it is. Okay. Sorry. Oh, shit. Go back. Just shoot me. Okay. Now we're going to cancel other things. Water and H plus might also cancel out. So there's 3 waters over here, and there's 4 waters here. So this is now just 1 water. There's 6 H pluses here, and there's 8 over here. So now this is 2 H pluses. Okay. So let's add them up, write it down. So 3 sulfite, 2 permanganate, and 2 H plus. Come on, son. Okay. And then this side is 3 sulfate, gone, and 2 manganese 4 oxide, and a water. Okay. That's balanced, but this is acidic, and we have to make it basic. Okay. And you've seen it a couple of times already, but this is the same reaction. I made it look nice. Okay. Now, to make it basic, what we're going to have to do is we're going to have to add OH minus that's equal to H plus. Okay. So we have 2H plus. So what we're going to do is we're going to add 2OH minus. Okay. But we have to add it to both sides. Okay. Then we're going to say, okay, remember if you have an H plus and an OH minus, that turns into water. So 2 H pluses and 2 OH minuses makes 2 waters. Okay. Now we have water on both sides. So this water and this water will cancel out. And now our final answer is them just rewritten to look nice. 2MnO4 minus, phase labels on the final answer. 3 sulfite. Now this is a water, liquid. Other side is 3 sulfate. Damn it, I keep bumping things. Okay, 3 sulfate. Why did it, oh, God damn it. I'm sorry, this is not going to be the highest quality video. Getting back into the swing of things because I haven't made a video in a while, so. Okay, and this is aqueous, 2MnO2 solid and 2OH minus aqueous. Ultimately, the order that you write your reaction doesn't matter as long as all the reactants are on the reactant side and all the products are on the product side. I'm sorry that was awkward, but we're trying to get through these steps. Let me go back and remind us what we did. Okay. Balance it like it's acidic. So we did this. Balance all the atoms that aren't hydrogen or oxygen. Balance the hydrogens. No, balance the oxygens by adding water. Balance the hydrogens by adding H plus. And then balance the electrons by adding them to the more positive side. That's what we did here, right? 2 here, 3 here. Then multiply if we need to, which we did here. I rewrote them so it looked nicer. And then add them together and cancel stuff out. Then once they're canceled and you're acidic, we have to add OH minus to both sides, equal to the H plus on that side, so that we get water and then cancel any extra waters. Okay. There are extra examples in my notes. If you need them, let me know if you need anything, and I will catch up with you later.